Hi, today I'm going to share with you guys about one of my projects that I made, which is the Wi-Fi LED. What this one does is basically you just connect to it over Wi-Fi using your tablet or any other mobile device, or basically Android or iOS. Open a web browser and open connects to the IP address of the device. Then you can control the LED. So I'll try to turn it on. This one is using 3.7 volt lithium ion battery. I'm just using a plain wires as its connectors, just kind of rough. So I try to connect it. Now it's already turned on. Try to connect it using my device. So it's fine. Wi-Fi LED. So I can't find it here. Hang on. Oh, there you go. It's already connected. Alright, so once it's connected, I can go through my web browser, type in the IP address, and right now it's already up here, so I'll just refresh that. I'm using Google Chrome, and it takes a while to load the page since it's not a quite high-speed device, but the ESP8266 is pretty robust, and it runs a system on chip, and it's pretty powerful. It runs at 80 megahertz, and it doesn't matter for any drop-down performance except wireless transmission. So now it's already loaded the page. So we have two buttons in here, so on and off. So if I press on, it might take time for startup, and as you can see, the LED turns on. If I press the off button, it turns off, and press on when it turns on. So it's pretty responsive. I'm using a JavaScript and HTML. So once the page is loaded, the only thing that it's currently working is the JavaScript on the web page. So it's only sends and receive data on and off without ever having to refresh the page. So yeah, the reason I made this project is for it makes things easy for you guys to develop your own projects. So I have the example circuits and the example source code, so you can write your programs much faster or easier. That might help you guys. So that's what most engineers do. But yeah, it runs on normal lithium polymer battery, 3.7 volts, and here's the circuit. I hope you guys can see it. There you go. So it's basically just an ESP8266. So the circuit's pretty simple. We have it has 8 pins, so we're not going to use all of it. We only use for the supply. As you can see, we connect the VCC and ground pin, normal always to ground, but the VCC pin, or the supply positive pin, I added 2 diodes. It's basically 1N4007 diodes, which is right here. As you can see right there's 2 diodes there. The reason I added that is because ESP8266 only runs on 3.3 volts, so anywhere more than that it might destroy it. So what it does is it drop every 0.3 volts. Since this is actually a germanium diode, I already measured the output voltage drop for the diode, and it's 0.3 volts drop. So it's basically stabilized. So if it's 4.8, dropped it at to 0.6, you get somewhere around 3.3, 3.6. The maximum this Wi-Fi module can go is 3.6 volt. Now that's for supply rail, and the 0.01 microfarad right here is used as a decoupling capacitor, which basically acts as a to reduce any voltage spikes. Since this thing is transmitting some things at 2.4 gigahertz Wi-Fi, since it's a Wi-Fi and wireless, it consumes pretty much a lot of power. This one, ESP8266, actually consumes quite a lot of power. That's around 300 milliamps max at peak actually. So this is pretty hungry for power. So that's where the decoupling capacitors really matters. Now moving on to the code, I'm using Arduino IDE 1.6.5, which is the current version that actually works. If you use version 1.6.6, it's actually having a problem with its library. so that it's better to use Arduino version 1.6.5. So I'm using external editor. I'm not using the Arduino IDE itself because I'm comfort with external editor like Sublime. So I've used external editor settings, and here's the code. I'm not gonna explain all of it because I assume that you have the basics of Arduino and electronics, so I don't need to explain all over again. So we have the constant we have a variable for the Wi-Fi access point settings, Wi-Fi LED, what you seen earlier, and the password. So I am using GPIO2, or assigned as pin number 2 on ESP01 I'm currently using, and sets the web server as port 80, which port 80 is basically used for any web browsing for any web browsers. So inside void setup, just starting serial communication, set up pin mode, digital write, and we set up soft access point. We set up the access point, start the server, and sending me a message. So when the client is available, which means I'm connected to it, trying and sending something, it's indicating there's a new client with timeout, so that it doesn't wait too long for me to wait for the data to arrive when actually the client already disconnected. So when I receive a request, then I check for any data or commands. If I receive LED on, I'll turn the LED on. If I receive LED off, then I turn off the LED. If I don't receive any of this, which means I'm requesting a web page, so I'm just sending the main HTTP response header and start sending the whole web page. As you're wondering, how do I wrote all this? Well, basically this is a standard basic HTML page I wrote using like this one. So this is the real page. I wrote it or converted into this. So to do that, I use another program called Visual Basic. I wrote a program that turns each line of the code into start with client printf, and it ends with, well, a double quote and a bracket and a semicolon. So I wrote a program to do that for me so that I don't need to type in one by one. And yeah, this program is really helpful. So what I type in, for example, like something here, so if I auto code, it adds in between this first sentence and last sentence. I'm not sure if I said that. I'm not sure it's sentence right, but yeah. So I name it auto code. Yeah, I'm not sure what to add, what to name it, and even have the copy to clipboard features. It's really useful. So this is the main web page, basically HTML with JavaScript in it. So it also has support for mobile screen size, so you don't have to zoom in, which is really convenient. And so this is the main page. We have the button itself and the script itself. Oops. So this is the main function. We have function for LED on and function LED off. Whenever I click one of these, it's called on these functions. So you can add more buttons and add more functions with different data that are being sent, like this one. It uses it uses HTTP GET request, so it sends LED on if I press the on button, and it sends LED off if I press the off button on the web page. And that's pretty much it. So it's not really complicated, and it's really easy to playing with. So you can write. For now you can write your own program much easier and start using it, hack it, and make it and do anything as much as you want. Thank you for watching.